everyone. Let us start the next module. Before going to discuss about the determinants, first let us recall about the matrices and its properties. So what do we mean by matrix? As we all know, the matrices are denoted by the capital letters A, B, C, D, etc. So a matrix is nothing but a rectangular array of scalars or numbers. So usually presented in the following form. That is, A is equal to A11, A12 and so on A1n, A21, A22 and so on A2n and so on AMN, AM1, AM2 and so on MN. So this is the rectangular array of numbers or scalars. So here the horizontal list of numbers are called the scalars. The horizontal list of scalars are called the rows and the vertical list of scalars are called the columns. So what do you mean by matrix? A matrix is nothing but a rectangular array of scalars or numbers. So the horizontal lines are nothing but the rows and the vertical lines are nothing but the columns. So here the rows of such a matrix are the M horizontal list of scalars. So here I have presented the list of scalars like horizontal list of scalars like A11, A12, A1n, A21, A22, A2n and so on, AM1, AM2 and so on, AMN. And the columns of A are nothing but the vertical, that is n vertical lists of scalars. So which is presented like A11, A21 and so on, AMN, A12, A22 and so on, AM2, A1n, A2n and so on, AMN. So the element Aij, called the ijth entry or ijth element, appears in ith row and jth column. So such a matrix is denoted by A is equal to, within the parenthesis, Aij. So a matrix with m rows and n columns is called m by n matrix, which can be written as m cross n. So here this m cross n is called the size or the order of the matrix. So a matrix is a rectangular array of scalars or numbers. So m by n matrix is nothing but the order or the size of a matrix. So the horizontal scalars are nothing but the rows and the vertical scalars are nothing but the columns. So this is about the definition of a matrix. Next, let us moving on to the operation. So like the arithmetical operation, addition, subtraction, multiplication. So here the matrix will be added or multiplied. So here the addition of two matrices will be like this. Let us consider the two matrices A and B of the same order. Let A is equal to Aij and B is equal to Bij of same order. Then their sum A plus B or their difference A minus B. So gives another matrix. So which will be obtained by adding or subtracting the corresponding elements of A and B. So addition is possible only when the matrices of same order. So let us go to the scalar multiplication. So when we have a matrix, say Aij, if you want to multiply this matrix by some scalar, say k, then we'll get another matrix which is denoted by Ka, which gives k times of Aij, which means the scalar will multiply to each and every element of the matrix. So this is called as the scalar multiplication. Next, how the matrix will be multiplied. So in multiplication of the two matrices, so here the number of columns of the first matrix must be equal to the number of rows of the second matrix. Then only the multiplication will be happen. So let A is equal to a matrix of order m cross n and B is a matrix of order r cross p. So AB will be multiplied if and only if the number of columns of the matrix A will be equal to the number of rows of the matrix B. So here the multiplication gives another matrix. The multiplication will be like the ith row of the matrix A will be multiplied with jth column of the matrix B, which gives the first entry of the matrix B. Similarly, we have to multiply the other rows and other columns of the matrix A and B. So before the multiplication, so we have to check whether the number of rows of the first matrix are equal to the number of columns. The number of columns of the first matrix must be equal to the number of rows of the second matrix. If they are equal, then only the matrix will be multiplied. So this is about the operation or the matrix operations, that is addition, multiplication, that is scalar multiplication, and the matrix multiplication. Next, let us discuss about the type of matrices. As we all know about this, so we have types of matrices like the equality of matrices, row matrix, column matrix, transpose of a matrix, etc. So let me highlight a few important types. So when we say that the matrices are equal, say A and B are two matrices. Suppose A is equal to B. When we say the matrices are equal, if they have the same size and the corresponding elements are equal, then only the matrices are equal. So what do you mean by row matrix? A matrix with only one row is called a row matrix. So here I have given one example. A is equal to 1, 0, 2. Similarly, a matrix with one column is called a column matrix. So the column matrix will be presented as A is equal to 1, 0, 1. So the next type is a zero matrix. So zero matrix is denoted by O. So a matrix whose entries are all zeros, such a matrix is called a zero matrix or null matrix. So here I have given an example whose size or the order of a zero matrix is 3 cross 3, where all the elements are zeros. So the next type is transpose of a matrix. So the transpose of a matrix A, which is written as A transpose or A dash. So we can denote the transpose of a matrix by A transpose or A dash. So it is the matrix which is obtained by writing the columns of A in order as rows. So that is interchanging rows to columns or columns to rows is nothing but the transpose of a matrix. So in other words, so in general also I have presented the transpose. Here I have given one example. So 1, 2, 3, 4, 5, 6. The transpose of this matrix gives 1, 4, 2, 5, 3, 6. So here I have taken the example whose order is 2 cross 3. After the transpose, we get a matrix of order 3 cross 2. Next, square matrix. So the square matrix is a matrix with the same number of rows as columns. So always the size or the order of a square matrix is n cross n or n square matrix. See the diagonal matrix is nothing but the diagonal matrix of A consists of the elements with the same subscripts A11, A22, A33. That is from the left top corner to right bottom corner is nothing but the diagonal. So all the elements will be having the same subscript, all other elements will be 0. So that is defined as the diagonal matrix. The next type is the identity matrix or the scalar matrix. So identity matrix and the scalar matrix are nothing but the diagonal matrix. So wherein in the identity matrix, all the diagonal elements will be equal to unity. In the scalar matrix, we may get the scalars like other than the unity, but all the scalars should be same. So always the identity matrix will be represented by I. So the nth order identity matrix is denoted by IN with the suffix n. or simply we can denote it by I. So except the diagonal entries, other entries are 0, where all the diagonal entries will be equal to 1. That is called as a scalar identity matrix. So when we multiply an identity matrix to any other square matrix, we will get the same square matrix. So for any scalar k, the matrix ki that contains k on the diagonal and 0s elsewhere, that is called the scalar matrix. So here I have shown the example of an identity matrix and a scalar matrix. So I is a identity matrix of order 3 cross 3. Say the except diagonal elements. Okay, all the diagonal entries are unity, other elements are zeros. So phi I is a scalar matrix where the diagonal entries are not unity. If all the entries are unity, then we call it as identity instead of scalar. So if we have the other elements other than 1, then we call it as a scalar matrix. So the next type is symmetric and skew-symmetric. So if transpose of A is equal to A, then we call A as a symmetric matrix. If transpose of A is equal to minus A, then we call the matrix A as skew-symmetric. So non-singular matrix. So to define the non-singular matrix, so let us consider a square matrix A. So A is said to be invertible or non-singular if there exists a matrix B such that AB is equal to BA, it should be equal to a unit matrix. Okay, so if we simplify this, we'll get B is equal to A inverse I, then B is the inverse of A. So A inverse is invertible or B is invertible. Then the important type is the diagonal or the triangular matrices. So what do we mean by diagonal matrix? A square matrix, see the diagonal matrix is denoted by capital D. So a square matrix D is equal to Dij is a diagonal if its non-diagonal entries are all 0. So it is denoted by D is equal to diagonal of D11, D22 and so on Dmn. Non-diagonal entries are non-diagonal entries means except the diagonal all the entries will be equal to 0. So then we call such a matrix as diagonal matrix. So this is the representation. D is equal to Diag, diagonal of D11, D22 and so on Dmn. So we can represent the diagonal matrix by using this notation, or we can represent it by this. Then what do you mean by triangular matrix? So in triangle, when we concern with the triangular, so here we have the two terms for the triangular matrix. So one is called the upper triangular, other is called the lower triangular. So first I will define. Triangular means either it may be an upper triangular matrix or lower triangular matrix. So upper triangular or simply a triangular means if all the entries below the main diagonal are zeros. See, here I have shown, I have taken a 2 cross 2 matrix and also a 3 cross 3 matrix and also a 4 cross 4 matrix. See, below the principal diagonal, if all the elements are zeros, then such a matrix is called upper triangular matrix. So lower triangular means above the principal diagonal, if all the elements are zeros, then such a matrix is called lower triangular. So these are the types of matrices. Next we have some basic properties with respect to addition, scalar multiplication as well as the multiplication. So I have highlighted the few properties on transpose operation also. You can go through it. So this basic definition of matrix. So let us define the determinants. So now let us discuss about the determinants and its properties. So what do you mean by the term determinant? So when we come to the introduction part, so we are all aware how to find the value of a determinant, how to find if we have a matrix, then how to expand it if it is a 2 cross 2 or a 3 cross 3 or a 4 cross 4 matrix. So in introduction part, determinants. So in linear algebra, the determinant is a scalar value that can be computed from the elements of a square matrix and which encodes certain properties of the linear transformation described by the matrix. So the determinant of a matrix A is denoted by det A or modulus of A, single line we will use to denote the determinant. So here the definition will goes like this. If A is a square matrix of size n cross n, then determinant A is defined as, so here I will take a 2 cross 2 matrix to define the determinant A. Let A is equal to A, B, C, D. Then what is the determinant of this 2 cross 2 matrix? So this is the notation dt of A, or we can use the single line modulus A or determinant A, which is equal to, with a single line A, B, C, D, which is equal to, so the value gives AD minus BC. So for a to expand a 2 cross 2 determinant, so we have to multiply the elements, diagonal elements, minus opposite diagonal elements, BC. So AD minus BC. A 2 cross 2 determinant will be very easy to expand. So a determinant of a square matrix is a single number. So and the number contains an amazing amount of information about the matrix. So here I have written one more example, that is to find the value of determinant A of a 3 cross 3 matrix.